Hola a tots. Benvinguts a la jornada d'alternatives en fertilitzants d'origen convencional que fem dins el cicle de jornades sobre insums controvertits, que està dins el marc del projecte europeu Orgànic Plus, del qual l'Escola Agrària de Manresa en forma part, juntament amb altres entitats. Welcome to everybody. Today is the conference of alternatives in fertilizers from non-organic origin inside the cycle of conferences on contentious inputs in the framework of the European project Organic. This project, which l'Escola Agrària de Manresa is involved, together with other European entities. Els vídeos que veureu a continuació han estat gravats per experts de tota Europa que han estat treballant en aquests temes d'inputs controvertits i són en anglès subtitulats al català. Hi haurà un torn de paraules al final, que serà cap al voltant de les 11:15, 11:20 més o menys. All the videos are in English with Catalan subtitles, and there will be a round of questions at the end, around 11:15, 11:20, for all of you make the questions to the persons that will attend, to the speakers. Totes les presentacions estaran disponibles al RuralCat a partir del mes de juliol, tot el cicle de jornades. All the presentations, all the video recordings, it will be available at RuralCat during the month of July. Doncs res, espero que vagi bé i parlem després.
Hello and welcome to this introduction of our international course in contentious inputs in organic agriculture. It's held at the Scuola Agraria di Manresa in Catalonia, and I will give you the introduction. My name is Ulrich Schmutz, and I'm the coordinator of the Organic Plus project. I'm also a professor at Coventry University. We have a center, it's called Ryton Organic Gardens, and it's a center for agroecology, water and resilience. So you find my details there. And I will give you a little bit of an overview of this course. So then you have a good way into it in the following sessions. So welcome again. So we are a team of two large EU-funded projects called RELAX and Organic Plus. I'm the leader of one of them. Lucius Tam is the leader of the second one. And together we had 8 million euros funding of 4 years. And we are now in our final year, and we have a lot of results to share with you, but we haven't solved all the issues. So I want to give you a little bit of a issue where we are now. Organic farming has phased out contentious input a long time ago. It's something which has been done, and it's part of the DNA of organic movement. So it started with phasing out chemical fossil fuel fertilizers. We don't use them, and that's part of the organic regulation. We have phased out synthetic fossil fuel-based pesticides. There's also no GMOs. And there's also quite strict regulation on animal cruelty, or on a positive word, how to care about animals. So the word organic or agroecology, biological agriculture aims to be a fairer, more ecological, more caring and healthier system innovation. These are also the principles of the organic movement. However, it is not perfect. So we need further improvements to organic. We can't just stay there. And this is in some way the kind of organic plus principle which we want to share with you, and which you also as a farmer or advisor are part of in a way to continuously improve organic. So I'm going a little bit back in a way to set the context of this course So let's go just back before we look forward. So organic started almost 100 years now with a movement called organic biological farming and also biodynamic farming. So we go back quite a long time. There's a lot of history there. And then in 72, there was formation of an international, so both of those earlier things were a bit more in Central Europe, Switzerland, and what is now Poland. And then there was an international movement, the International Federation of Organic Agricultural Movements, that was founded in Paris. And this was a time before there was regulation on organic farming. And this came in Europe and in the EU in 1991. And ever since, regulation has been done. So our work, in a way, is to look where we are now. So are we in this year, 2022? We have just had an updated regulation on organic farming, and obviously have to say that there is also a big war, obviously, now going on in the Central Europe, which is also an issue of some of the contentious inputs we say later, especially oil and minerals. But we'll move on with that and want to look more forward. So what was the project about? So looking forward is going to 2030. So we will have an official target from the Green Deal of the European Commission that we will have we aim for 25% organic land use in the EU. This is quite a big aim. Some countries like Germany, Austria, some smaller ones, they aim even further for 30%, and some of them have already achieved that. Liechtenstein, I think, is the highest, over 40%. So this is the big setup where we are in. And going now into the course, as I mentioned, we have those two projects. You can see their title. They both have a website where you can study and Google that in more detail. And both projects were kind of organized a little bit. We knew each other already that we were applying. It is still competitive, and other projects were not funded, but we try to be very synergistic always, so that we can kind of, in combination, can solve these issues of contentious input. So your whole course now will then tackle the contentious inputs we see now in organic farming and how we can overcome them in detail. So we have to go into the detail of copper. We have to go into the detail of mineral oils. We will present you experiments, not everything we have done in this course, but just selected information and results on that. And then we will go in the following days, we will hear more about vegan fertilizers, you will hear more about peat and the replacement of peat, you will hear more about plastic use. All of these are identified contentious inputs. And then we have a big section also on livestock farming, because there we have also a lot of contentious inputs, synthetic vitamins, antibiotics, anthelmintics, so this is the treatment against worms, and also the animal bedding, which is often with conventional straw, which then has the pesticides in it as well. And we are concerned about the animals eating them, but also contamination. We also had a big part of research on social science. We're not covering that in this course, but we will work also on the modeling, on the phase out. So you will get information on how, on the life cycle assessment and the social assessment, socio-economic assessment of the alternatives, and how we can model the phase out. So this is a little bit, and we follow this same template in all the different sections you have. And then you obviously have also 2 days of on-farm visits, because all this information needs to be put in practical, real farming changes, because otherwise it doesn't really make any difference to the environment and has limited or no input, which is obviously impact, which is important. So based on the information and the the work we are doing, looking at alternatives, we then make recommendations mainly to the European Union and also other sector bodies who may have standards, when to phase out some of these remaining identified contentious inputs. So, for example, and this is not, it's like a planning tool here. It's not the final answer, but we think the phase out has to be staggered. So some of the things we can phase out fairly quickly. For others, we need at least 10 years more time, research, alternatives need to be prepared. We don't want to ruin the organic movement by going too fast, but also we want to reach 30% or 25% in the next decade. So we need to do that in a growing market. And then there's others like antibiotics, which may take even longer to completely phase out. However, that may actually not be true, because depending on the research we do, it could actually also change. So this is another overview. So, and I also will finally end that we also already, because we are at the end of the project, we are thinking about the next steps. So I call them phase out mission proposals. So we want to have further research commissioned by the EU, and that hasn't been done yet. Also parts of it have. And they would be slightly different, because our work we're showing you was work which was more commissioned in research labs and trial sites. And this wider phase out would be even more connected to farmers. We already connected a lot to farmers in our project, but an innovation action would also include farmers as micro enterprises. So then we can do commission trials on farms, so that everyone is kind of has help in a way to try the alternatives and also create. We will hear, this is another word I haven't mentioned yet. For some of them, we also think you need a system solution, which means a redesign of the organic system, which in many cases is a little bit, what we could say, old-fashioned, because it was converted from conventional farming. So we have a system like in apple trees, citrus, which worked really well under the planting densities of conventional agriculture. Then it was converted to organic, and now it doesn't really work so well. So we need to have a system redesign, including agroforestry and mixed farming, so we get a whole new system where we don't have these problems. And this is all from me now. So I thank you for your attention up to now. So I would say, please enjoy the course, and obviously some of you may be more interested in horticulture and other more in livestock, and that's clear. But I think this project has also helped, because it has so many issues, help bring the organic movement together and remind everyone that there is this interconnection between mixed farming, livestock, and even in horticulture, where you can do that. And then my final word is, please also take some action. Do some experiments on your farm. Try some of these alternatives and see how how it goes. And then I hope we can create an organic plus system, a world almost, where we do not need all these fossil fuel products. Obviously, a main thing is also the climate change. Peat, for example, if we don't use it, we can protect all the peat bogs on our planet, and they have an enormous potential to mitigate climate change. So it may look like a small step for you on your farm, but it is actually quite important to come to this bioeconomy or cyclical economy, as we call it, on a larger scale. So thank you again for your interest in this, and I hope you enjoy the course. Bye.
Yeah, hello everybody. We're here today for the webinar on alternatives to fertilizers from non-organic sources in organic agriculture. Let myself introduce me again shortly. My name is Sabine Zikeli. I'm heading the Center for Organic Farming at the University of Hohenheim in Germany. And within the project Organic Plus, I'm heading a subtask on these alternatives to fertilizers from non-organic sources in organic agriculture. So if we look at this topic of fertilization in organic farming and the big question, why are fertilizers from non-organic sources contentious inputs, we first have to look at the organic ideal of nutrient management. So in organic farming, the basic idea is that we do rely very much on an internal recycling of nutrients on farm level. That means we do fix nitrogen from leguminous plants and we use the soil sources for organic crop production. And a part of the crops are going into feed, which is then fed to the livestock. The livestock itself generates or produces organic manures. And these manures are again used to fertilize the crops. And so we have this internal cycle of nutrients within the farm. However, a part of the nutrients is removed from the farm by the plant products which are sold, and another part of the nutrients is removed from the farm as well by the animal products which are sold. So we need additional nutrients to balance these losses via the outputs. And this becomes even more crucial when we look at stockless organic farming systems or even vegan organic farming systems, which now become more and more important in organic agriculture as well. Where do these nutrients come from? Because this is actually the basic point when we talk about the contentiousness of these inputs. So a lot of these nutrients, these external nutrients which we are using in organic farming systems, they are originating from external sources. And in those cases, they are originating from conventional farming systems. So we do have a strong import of nutrients which are resulting or originating from conventional farming. That means that a lot of the fertilizers we are using, for example, in organic vegetable production, which are based on horn grit or feather meals or pig bristles, come from conventional intensive animal husbandry. And that is also the case for conventional manures and conventional slurries. So these systems are definitively not in line with organic farming, with the organic farming principles. So these types of organic husbandry are not accepted in organic agriculture, and that makes them contentious. In addition, in particular, the horn grits come very often from other countries like India, like Pakistan. So these are, or Egypt, so these are imported fertilizers, which are of course also not sustainable. And in addition, other fertilizers which are used, for example, from sugar production, vinasse from sugar production, these fertilizers, they may contain contaminants, either herbicides, in the example of the vinasse, or the manures may also contain antibiotics. Now we come to the question why these imported these external fertilizers from non-organic sources may be contentious. So these fertilizers, which we need to refill or to replenish the nutrient balances in our organic farms, they come in most cases from conventional farming systems, either as conventional manure or slurries, but it can be also slaughter residues like horn grits, feather meals, or pig bristles. And these conventional farming systems practice organic animal husbandry that is not accepted in organic farming. So that makes them contentious. In addition, some of these fertilizers, in particular the horn grits, are often imported from countries like India or Egypt, and that of course is also not sustainable. In addition, these contentious inputs from conventional systems may also contain contaminants. That could be antibiotics in manure or in slurry, or it could be herbicide residues in plant products from food production. For example, in vinasse from sugar beet production, we may find herbicides leading to detrimental effects in the organic crops, in particular in plant-led production. So we do need alternatives. And that is the topic in our work package in Organic Plus. We try to implement a system approach where we find new fertilizers which can be used in organic farming systems to avoid the use of contentious inputs. And we do have 3 different types of fertilizers which we are testing in our work package, and that we sum them up under the name urban, vegan, and resid inputs. Let me now explain a little bit urban, vegan, and resid. What do we mean with that? So the fertilizers which are derived from urban sources, that's the fertilizers called urban, they aim at closing rural-urban cycles. That means we will use residues from urban processes. In that case, in our case here in this work package, we do use biogas digestates from household waste, from kitchen waste, that is produced in biogas plants, and we use that as a fertilizer. So that would be a typical fertilizer of our urban products. Then we do have the fertilizers which we call vegan, and these are fertilizers which are focusing on the improvement of internal nutrient cycles within the farm. Here we focus a lot on the nitrogen fixation within the farm. So in this case, we are using fertilizers which are based on legumes, and in some cases also on non-legume plant materials. You see them also here. You see here on the right-hand side some clovergrass pellets or clovergrass silage that would be typical fertilizers of these vegan origin. And then last but not least, we do try to find other sources which are not contentious. And one type of source at that in that conditions is residues from organic food production. That is the tofu whey here. The tofu has the way the soybean has been grown organically. Tofu was produced from that, and the whey is a residue which currently is disposed of in the sewage system. So there is no use for it. However, it contains important mineral nutrients which we could use in organic agriculture. So we try to recycle these tofu whey within an organic farming system. Another important input could be marine materials, and that could be fish hydrolysates from marine fish production or fish catches. So that would be the very last step after a lot of other products have been derived from the fish. So the very last leftovers would then be hydrolysated, and these hydrolysates could be used in organic agriculture. And another marine source would be seaweed. So the seaweed is grown or grows naturally in the sea, and that can be harvested and then again used in organic farming. And my colleagues, Anne-Kristin Løes and Carolin Weiler, will give you a closer look at the results on our fertilizer trials.
Good morning. My name is Anne-Kristin Løes. I work at the Norwegian Center for Organic Agriculture, NORSØ, and I have the pleasure to talk to you about marine-derived fertilizers, a new fertilizer product. And we have been studying marine-derived fertilizers at NORSØ for some years, and we have had funding from Organic Plus project, but also from Møre og Romsdal County Municipality. And Møre og Romsdal County, that is the region where NORSØ is located. So talking about locations, if you look down here, the map of Norway, you see this red arrow. That is where NORSØ is located, on the coast of northwestern Norway, So you see we are very near to the ocean, and around us there is a lot of marine industry. And Norway has a very long coastline and a lot of marine industry, and also a lot of residual leftover materials, which are sometimes not very well utilized. So we can work with fertilizers from 3 main categories. The first one is captured fish, wild fish living out in the ocean and being captured. So you see a picture up here of the captured fish, such as cod and saithe, whitefish we call that, and also fat fish like herring. And residues of such fish is permitted to apply as fertilizer in organic growing. Then we have aquaculture, or maybe I should first mention that Norway captures about 2.5 million of live weight of such wild fish each year. In aquaculture, we produce almost, or not so much, but quite a lot, 1.5 million live weight, and that is mainly salmon for export. And the residues of raised fish are utilized 100% for feed. So it's not so much leftover which could be applied for fertilizer. Maybe you could apply the dead fish, but that is not permitted for safety reason. What you could apply is the sludge, the sort of, you could say, fish manure from young fish, which is raised in freshwater, but that is not permitted in organic agriculture. You see this is permitted for the wild fish, but not from the aquaculture fish. So that is why we don't concentrate or work anything with fish sludge in our studies of fertilizers for organic growing, but we work with seaweed. You can see here seaweed is something we can harvest along the coast, or we can cultivate it. Brown seaweed that grows very fast, and it is a rapidly growing industry. So we will have residues also from seaweed and from white fish. That is our main materials which we are working with. And here you see a picture of the residual materials from white fish, such as heads and intestines, and also then here the backbones when they make fillet, and it's still a lot of fish flesh here, but that is has been used a lot for feeding fur animals, but now the fur animals is an industry which is rapidly declining. So then there is a lot of leftover material here. And of course, there is a lot of work carried out. If you look up here in the value pyramid, especially in the top of the pyramid, it's a lot of research carried out, trying to find new feed products for pet animals or food, pharmaceuticals, but not so much here, more in the bottom of the pyramid where we are working with materials for fertilizers. So we need more things to happen here in the bottom of the value pyramid. So our main products for fertilizer experiments, they had to be available nearby for a cheap price. So we have been working with the captured fish, with residual materials from captured fish, which has a lot of bones in it. And then we have been working with algae fiber. That is harvested seaweed, which has been dried and grinded and then extracted by chemicals. And then you sell liquid fertilizers. That happens at the factory not far from here. But then the residue is algae fiber, and they don't know what to do with it. And it still contains many nutrients. So that is why we work with fish bones and algae fiber. And I think it's quite interesting to know that about 100 years ago, Norway had a significant industry of marine-derived fertilizers. They were called guano factories. And you can see here this old picture from 1916 from a place called Steilnes. These are the workers. You see both men and women here in front of a very, very big heap with dried cod heads and maybe also some other fish. And that was all made into guano with a lot of phosphate in it before the mineral fertilizer industry grow very rapidly, and so all the guano factories were closing down. Maybe now we have to make them open again. So here is a little bit more about how we get hold of our materials. So when these fish bones, could be cod heads or backbones, when they are leftovers, they could be grinded, and then you have to conserve them in some way, otherwise they will putrefy. That can be quite risky. It can be a big explosion if you have a big amount of this material. So either you have to acidify it by formic acid, for instance, to a pH below 4, or you could dry it. But often it is hydrolyzed after acidification in such a big tank. And what happens then is what you can see here to the left side in this little plastic container, that after some months, the oil will dissolute and float up to the top, and then you have a big proportion here of solubilized proteins, and the oil and solubilized proteins, they can be applied as feed for fish, for instance. But then in the bottom you have sediments, and here in the middle you see a tank with such sediments with a dry matter content of about 50%, and then if you dry that carefully, you can use it for application in field. Maybe if you would like to put it into a pellet, you would have to grind it a little bit more, but that is a very good starting point for fertilization. And as you can see here, it contains a lot of nutrients. It has nitrogen, it has phosphorus, and it has calcium, very much. But it is not a well-balanced fertilizer, because in addition to nitrogen, phosphorus, and calcium, plants need a lot of potassium, magnesium, and sulfur. Those 6 are the 6 macronutrients of crop plants. So how could we achieve a more balanced fertilizer? Well, then it's very good that the seaweed actually contains a lot of potassium, sulfur, and magnesium. So here you see how they make this, they take this fresh seaweed from the sea, dry it, grind it, extract it, and then they make liquid product for sale here, and a lot is exported. And then after this extraction, you have this black paste, which you see here down to the left. That's the algae fiber, with a dry matter content of about 30%. Some nitrogen, if nitric acid has been applied for extraction, not very much phosphorus, but some calcium, and lots of potassium, magnesium, sulfur. So about 15 tons each week is made in this plant, and currently they incinerate it. And here you can see how we have applied both algae fiber and fish bones in a field experiment here. You can see the white particles are the fish bones, and the black is the algae fiber. So maybe it's good to mix these two materials for a more balanced fertilization. So here you see some more pictures of how we work with it in the field. Here we also had, to the left side here, we have some freshly grinded backbones of fish. And then we were very curious to see what happened when we bring this with a lot of fish material in it. What happens? Will it come many flies or many birds or maybe cats? But when we incorporated with this rotavator, it was no smell and no cat and no bird. It was okay, and the plants grew quite nicely. Before we can apply the algae fiber, we have to make smaller clumps of it. You see that in this picture down to the right side here. And the main fish product was this acidified fish bones. So we had this field experiment with 9 treatments and 4 replicates. Of course, we had a control with no fertilization, that's the light yellow ones. When we had a positive control, which was a green, called green organic, in Norwegian grønn øko. That's a dried poultry manure with some vinasse to make it a very well balanced fertilizer, but also a fertilizer which we actually try to get rid of in organic farming, because we want to be independent from conventional animal production. So in this field trial, we had then comparing 5 types of fertilizers at 2 nitrogen levels. So we had either 300 or 600 kilos of nitrogen per hectare in 3 types of fertilizers. That was this acid conserved fish bones. It was a mix of algae fiber and fish bones, where 70% of the nitrogen came from the fish bones and the rest of the nitrogen from the algae. And then this positive control, green organic, poultry manure. And then the algae fiber and the fresh fish bones, we only had in 1 nitrogen level, because we didn't want to apply so much algae fiber on the field, because then we were fearing that the ryegrass seeds, we had ryegrass as the crop, that they may not be germinating because the pH of algae fiber is very high. It's more than 9. And also the fish bones, fresh fish bones, we didn't want to apply too much, since that was the first time we tried it in field. And then you can say that 600 kilo nitrogen per hectare, that is very, very high, but we did this because we wanted to compare with an indoor pot experiment. And here you can see how the experiment looked like. We had ryegrass as the test crop, which could be cut several times. So we had 4 cuts altogether. And you can see here at in the middle of August, we're soon ready for the 3rd cut, then that the algae fiber, it didn't grow too well, but when you mix algae fiber with fish bones, it grows very well. And here you just see the yield results. So here the control, about 400 or 4 tons of dry matter per hectare. This is shown in gram dry matter per square meter. And then with algae fiber, not more than the control, a little bit less. And then the fish products were, and positive control were all quite good, and also this mix. And then the year after, last year, we grew potatoes in the same plots. And then it was quite interesting to see that then the algae fiber gave a quite nice residual effect, because then the potato yields were quite high after algae fiber. Here you can see the control, whereas mix and algae fiber, then it was much higher. So that's interesting that with the algae fiber, you have a big residual effect, whereas with the fish fertilizer, you have a very rapid fertilizer effect, which you maybe couldn't see on the last yield diagram, but which is very obvious in the field. And that we could also clearly see in another field experiment, which was established in 2019. Then we had only 5 treatments, just the same materials, algae fiber, mix of algae fiber and fish bones, and this green organic poultry manure and a control, and 4 replicates. But then we had oats as our test crop, and that was harvested while it was still green. And you can see the harvest day here on the photo. So there you see that for oats, the fish bones was a very good fertilizer, almost doubling the crop as compared with the control, whereas the algae fiber did not give any positive yield effect with the oats. But 2 years after, without any more fertilization, because the oats was a cover crop for lay, so then we had a 2nd year lay there last year in 2021. And then you see that the lay yields, sum of 2 cuts, they were much bigger with algae fiber and mix when that was given back in 2019, whereas the fish bones and the green organic poultry manure, then the yield was not so high anymore, because the lay hadn't got any more fertilizers since 2021. But this is quite interesting with this big residual effect. But of course, it's not only good things. It's not only nutrients. It's I already mentioned that the algae fiber has a bit high pH. Another issue is that it also has some heavy metals or potentially toxic elements, and especially arsenic, AS, and cadmium, CD, is in a concentration which is too high if you compare with the limits in the regulation for organic growing that has a limit of 0.7. So this is above this limit, and that organic regulation doesn't set any limit for arsenic, but in the general EU regulation is 40. So then it's below, but it's still quite high if you compare with other materials like fish, for instance, and poultry manure. So this is something we should consider. So maybe good not to apply too much algae fiber at a time, and maybe mix it with something else. And also, like I said, it's not so well balanced. We need to merge different materials to get a balanced, complete fertilizer. But there could well be occasions where you could make use of a fertilizer which has a very rapid growth effect and is high in nitrogen and phosphorus, for instance, such an old grazing field, to have earlier growth in springtime could be quite useful. That would be a very interesting experiment to carry out with the fish bones. And maybe also in some horticulture system could be interesting with the nitrogen phosphorus fertilizer. I mentioned this challenge with the heavy metals, but one nice thing is that with these potatoes that I showed you, that they had a good, they performed well when, sorry, now I clicked one too early. When I said that the algae fiber had a nice residual effect in the potatoes, but what about the arsenic in the potatoes? Because the algae fiber did increase a little bit the arsenic content of the soil, of course. Well, it was no more arsenic in the potatoes. So that, and all the treatments were well below the safety limit. So it seemed that even if it was increased arsenic in the soil, it was at least not increased arsenic in the potatoes, which is good to know. But we need still also to take care if you apply this material to soil, because ruminants are very, they have very strict demand for minerals, so they cannot take too much potassium in their roughage. So that is also something to be aware of. So we have several things that we still need to study. But now I come to the conclusion. There is definitely a high potential for application of marine-derived fertilizers in organic growing, but we need to develop a complete value chain for it. And as I mentioned, with the potentially toxic elements and a mineral balance in feed and so on, there are several issues still to study, and also more issues to study which materials to merge and how to process them to get the complete fertilizer, which is easy to transport and store and spread in field and so on. But I want to end up with this view of mine that I think we put too much emphasis now in the top of the value pyramid. So I think that we should turn that upside down for a while. I think research and innovation funding bodies, they should turn the value pyramid upside down and do more here with the basic needs and do more on fertilizers and not only look out for well-paid pharmaceuticals. And maybe we need to put a fee on high-value products such as pharmaceuticals to cover costs for a complete utilization, so that all materials can be taken care of in a nice way, because it's not good to incinerate materials which contain a lot of valuable plant nutrients. So that was my final word. And if you have something to ask about, I will be happy to respond to your questions, and maybe we can also have some discussion. Thank you.
Hello, my name is Casper Laursen, and I'm from the Innovation Center for Organic Farming in Denmark. And today I will present for you results from organic field trials where anaerobically digested food waste is used as fertilizer in spring barley. We performed the trial with support from the Organic Plus project, among others, in both 2019 and 2020. And so this is what the presentation is about, really. It's about recycling. The return of nutrients from the city to the farmland. And it's a good old organic principle, actually, that this illustration is about. Here we are collecting food waste, household waste that is used for biogas production. I'm sorry for the Danish texting here, but the waste is used for biogas production, and the residue from this gas production is returned to the farmland, which then produces new high quality organic products for consumers, for people in the city. And onto the agenda, first we will shortly touch upon organic agriculture in Denmark and our dependency of the conventional production. And then we're moving on to our experiences on using source-separated household waste as a fertilizer. So which products are tested, what is the value of the products, and does it contain any contentious inputs? At the end, we will shortly touch upon our ongoing research on possible contaminants in household waste. In organic agriculture in Denmark, we are fertilizing the soil or the plants to a suboptimal level, which makes us inefficient, and it also makes us non-climate friendly, or at least less climate friendly compared to what we want to be, what our ambitions are. But it all starts with a positive problem, really. The organic agricultural area in Denmark is quickly rising and has been for some years. And it now covers 12 to 13% of the agricultural landscape, which is, as you can see on the graph, approximately 300,000 hectares. The distribution of organic livestock, though, are unequally divided between the eastern and the western part of Denmark. And though it's a smaller country, it makes the distribution of organic fertilizer difficult. So organic farmers in Denmark often use conventional manure. And here you can see the distribution of livestock production, organic livestock production, and organic plant production in Denmark. And the blue dots are the organic livestock production, which are primarily located in the western part of the country. And the green ones are the pure organic plant productions that are primarily located in the eastern part of the countries. So there's almost no organic livestock production in the eastern part of the country. So especially in this part, farmers rely on conventional manure. And of course, the organic plant producers are all trying to use green manure and nitrogen fixing plants, etc. But they're still largely dependent on conventional manure. And it is allowed in Denmark to a certain extent. But are there any additional solutions? That's the question here. And this is where the idea of recycling household waste via biogas plants comes in. On the picture, we see one of the commercial biogas plants in Denmark. And we believe that it has the potential to make the organic agriculture more independent of conventional manure. And maybe it will even make the production more climate friendly. So now we move on to the field trials. And I will show you results from 2019 and 2020. This picture is from the start of one of the field trials, where we are applying fertilizer to the field, and among others, digestate from household waste. We're making these scientific tests of different recycled fertilizers, and we did it on 10 different locations in 2019 and 2020. The field trials are performed on regular agricultural spring barley fields, so not areas that are usually used for scientific testing, just regular real-life spring barley fields. And this picture is from one of the field trials in June, and the concept is that the farmer is just doing the sowing and the weed management as in the rest of the field, like he would usually do, and we just do the application of the fertilizer and harvesting of these plots in the field. So which products are contained in the field trials? Well, conventional pig manure is our reference. So the other products are compared to this conventional pig manure that we know very well in the organic agricultural system in Denmark. The next one is called Øgro, and it's a fertilizer product from pelleted meat and bone meal. It's well working and easy to use, but it's also very expensive. And then we have these three products that contains household waste. The first one, the one here, is a mix of materials with manure and household waste. And then we have two products that are based on 100% household waste. The first one, called Varga, is a Danish product, and the next one, Deka, is from Germany. These products on 100% household waste, they're not for sale anywhere in Denmark, but I know it exists in other European countries now. In the field trials, we are addressing nutrient content, fertilizer value, heavy metals, and some of the contaminants or the impurities, plastics among others. So this picture is showing collected and source separated household waste that only contains food waste, really. Household waste are collected in most households in Denmark already, and from every household by the end of the year. At least that's the political plan. The household waste is entering a pre-treatment plant, pre-treatment process at first, where plastic, glass, and other contaminants are removed. And that is before it is digested in a biogas plant, where it is transformed into gas that is used as fuel for transportation and as heating in household primarily, actually. And then the residue from this production is a fertilizer that is returned to the farmland. And this is how it looks like, the picture on the left-hand side. Digestate from household waste. Actually, it looks exactly like normal slurry. It has a similar consistency. The method of application is the same. The machinery for application is the same. And even the nutrient content is almost the same. And you can have a look in the table on the right-hand side afterwards, maybe if you're interested. We will hurry on from this to the fertilizer value. And for fertilizer value, we have the applied ammonium nitrogen on the horizontal axis and yield on the vertical axis. The first product that we apply to this graph is the slurry, the conventional pig slurry, and it behaves exactly like we expect, which is good. We have rising yield as a function of applied ammonium nitrogen, up to a certain point, after which it stagnates and maybe even declines a little in the end here. But we have significant increase in yield per kilogram applied ammonium nitrogen until around 80 kilograms of ammonium nitrogen per hectare. The next product, very quick, it is the meat and bone meal product, which is applied in two different amounts, 40 kilograms of ammonium nitrogen and 80 kilograms of ammonium nitrogen. And we have a significant difference from slurry for application of 80 kilograms of ammonium nitrogen on clay soils. But if we include very sandy soils, there are actually no difference between this product and the slurry that we usually use. The next product is a mixture of household waste and slurry, and it is shown by these red dots. And we have no significant difference from slurry to this product in fertilizer value. So from this, we conclude that household waste can easily be included in this biogas production without reducing the value of the fertilizer, the residue from the gas production. And the last two products, they are marked here with the blue dot and the brownish dot. And these last two products were the one that were based on 100% household waste, and the utilization rate here is equal also to pig slurry in a cross location of the field trials in both years. Yeah, so that will do it for the fertilizer value. Onto heavy metals, and this is actually just to show you that in relation to heavy metals, digestate from household waste is actually a much better and much cleaner product than regular pig slurry, especially when we look at copper and zinc. Here we have around 8 times less zinc and the same, also 8 times less copper in household waste, digestate for household waste compared to pig slurry. So actually a clean product in relation to heavy metals. The picture here on the left side is plastic removed from the household waste in the pre-treatment process. And it is primarily the bags, the plastic bags that the waste is collected in. The table shows the allowed levels on our current legislation of contaminants or these physical impurities in general when applying equivalent to 80 kilograms of ammonium nitrogen per hectare. And then we have the actual levels of contaminants, all bigger than 2 millimeters for this Varga products that were one of the products based on 100% household waste that we were testing in our field trial. So here I want you to pay close attention to the second line. In Denmark, we have a threshold for maximum allowed plastic per hectare and area covered. So the maximum allowed is 1 square centimeter per percent dry matter measured in 1 liter of pulp. Pulp being the input to the biogas plant after the pre-treatment process. And here, when applying 80 kilograms of ammonium nitrogen per hectare, the Varga digestate is well within the threshold, which is approximately 6.5 square meters per hectare. But the product still contains, or still the plastic in the product still covers around 3 square meters if it was all put side by side on the soil surface. And it still seems like a lot to me. We should be able to do better here. And the farmers that I talk to are not convinced either that this is good enough. Just applying plastic to the soil intentionally, it doesn't feel good. So we need to do better here. And then what else? We have repeated the trials in 2020 also, and we got exactly similar results. And since then, we've been working on gaining knowledge of contaminants in household waste and the probability of it potentially compromising the health of the soil. We're doing analysis on microplastic in household waste from commercial biogas plants and pre-treatment plants in Denmark in order to find out if there are anything, the amount that are less than 2 millimeters, smaller than 2 millimeters, how big an amount is that? And we are doing trials also on biodegradability of plastic in organic fields, where we are specifically focusing on the different kinds of plastic bags that are used for collecting household waste. Also, we are nudging consumers in order to improve the quality of the collected household waste. And we're working with farmers in order for them to get access to this fertilizer. And of course, the aim here is to convert additional agricultural area to organic production. And then the take-home message from here, we have a huge need to introduce new nutrients and new fertilizers to organic farmers in Denmark and specifically, but I suppose also in the rest of the European Union if we are to reach the goals for more organic agricultural area. And that is, of course, to improve the effectivity and the climate footprint of the organic production. And this has to happen without compromising consumer credibility, of course. We believe that recycling of household waste is part of the solution to that issue. Digestate from household waste as a fertilizer is similar to pig slurry in both application method, consistency, nutrient content, and fertilizer value. And it does contain low amounts of heavy metals, which is good. But it does contain plastic to some extent. Then there are also things that we don't know yet. So we're not finished with this research. Thank you very much for listening. If you have related trials or experiences in using household waste as a fertilizer, I will very much like to hear about them. And if you have further questions beyond what we have time for now, please contact me by email. My contacts are in the right-hand side of the screen here. Yeah, thank you very much.
So hello everyone, my name is Touliatos. I am a researcher at the Center for Agroecology, Water and Resilience, Coventry University. And I have been working with vegan fertilizers for the last 2.5 years during the Organic Plus project. And I'm going to talk to you about vegan fertilizers, as you can see in this first slide of my presentation. So to start with, what is vegan organic fertilizers? Where, very simply put, vegan organic fertilizers are plant-based organic fertilizers that don't contain any animal-derived products. So no manure, no blood and bone, nothing that comes from other animals. It's all, they're pure plant-based organic fertilizers. And some examples of them are, for example, green manures. So these are legumes or grain or other plants that we grow specifically to increase our soil fertility. So we either incorporate them or use them as mulch. Another example is compostees. So this is liquid fertilizers that we produce by steeping plants in water. Are very famous compost. So composting plant material is another vegan organic fertilizer if it doesn't contain, if we don't mix it with any animal-derived products. And legume meal, which is the most not so widely used vegan fertilizers, which is basically legumes that have been ground into a flour or a dust, and we use them as a usual like solid fertilizer, or make a liquid fertilizer by mixing them with water. So the question is, why should we use plant-based alternatives to manure and other like well-established animal-based fertilizers in organic horticulture? So the first reason is that some animal-based products are contagious, and as you know, in Organic Plus, we are looking at pathways of removing contagious inputs from organic certified agriculture. So some animal-based fertilizers are contagious because they can often come from non-organic sources, like from farms that that are not organic, and sometimes they can contain antibiotics or residues from pesticides and herbicides that the non-organic farmers have used. So that can be a problem because we bring in our organic system inputs that we don't want. And also, some growers might not have access to manure. I mean, it's not easy for everyone to have access to manure if there's no livestock around. So it's a really good alternative to use just plant-based fertilizers instead of trying to find manure on animal-based fertilizers. But also another really strong reason is that some growers, they just don't want to use animal derived products for ethical and environmental reasons. They're either vegans, vegetarians, or they are environmentalists, so they don't want to be part of the of animal husbandry for climate change and reasons that have been well documented. So at core, we, as part of Organic Plus, we used a mixed research methods approach to assess the sustainability and practicalities of vegan fertilizers in the UK. So the first research team was based around practical agronomical research trials at Triton Organic Gardens in collaboration with the vegan organic CSA called 5 Acre Farm. And this practical trial, in these practical trials, we investigated the efficiency and the efficacy of both well-established as well as new and novel plant-based fertilizers and green manures in producing high-quality vegan organic crops. And I will talk more about in detail about one of our trials. What was key about these trials is also that we tried to follow a whole systems approach. So we used some of the plants that we used were grown in the farm. So we tried to evaluate a whole system where the farmer grows their fertility through plants on the farm. And one example that we can see from our trial is that, as you can see in this picture, we had this polytunnel where we grew our vegan organic crops, and next to it we were growing comfrey, which then we harvested and used for fertilizer. So this was like a closed loop systems approach where we grow the fertility right exactly next to the place where we grew the crops. The second theme was more qualitative social sciences research. So it included visits to vegan organic farms across the UK to understand why they do what they do, how they do it, and if it is sustainable and efficient to do that. And to understand this, we use the software, a modeling software called RISE, which is used widely around the world by agronomists to assess the economic, social, and environmental sustainability performance of farms. And it is a holistic framework. So because it looks at these three key pillars of sustainability, so economic, social, and environmental, it's holistic, and it was really useful to understand how vegan organic farms perform in the UK. And at the end of the RISE interviews, when we put all the data on the software, at the end we get a polygon like this one, which then we can see in which aspects the farm is strong, in which it needs some improvement. So, and we will, during this presentation, I will talk about, this is not from our data, this is from a paper, from this one, but we had the same polygons from our data, and I will discuss more about the details and what we found out from our vegan organic farms. So first, I'm going to talk about the vegan organic trials that we did, the agronomical ones. So we used, in one of them, we used tomatoes as the test crop, and also what we found is that at the stakeholder session on the conference here in the UK, we found that a lot of organic growers use pelleted chicken manure on tomatoes. So first, I'm going to talk about the vegan agronomical organic trials that we did at Wrighton Organic Gardens. So we used tomatoes as our test crop, and we identified during a stakeholder session in a conference here in the UK that a lot of organic growers in England, they use pelleted chicken manure to just boost their tomatoes and improve growth and yield. So we asked the question, how can we replace, the pelleted chicken manure with a plant-based alternative? So, and this was, what was underlying this trial that we did. So the vegan fertilizers that we tested, we used comfrey liquid. So we basically had big barrels where we put a lot of leaves and stems of comfrey with water, left them for about 6 months, and strained it before using the liquid fertilizer. We use nettle liquid in the same way. We use the leaves and stems of nettle, and then strained them and took the liquid fertilizer. We use bean flour, so we use the broad bean Vicia faba flour, and we suspended it. We mixed it with water, and then we watered the tomatoes. And also, as a positive control, we use the commercial seaweed-based commercial plant-based fertilizer called ILEX. And we wanted to see how our DIY, homemade, homebrewed fertilizers compete to the commercial one. So these are the fertilizers that we use. And this is a picture where I am mixing in these barrels this should be the comfrey with water, and mixing it before straining it. So after 6 months, the clear water that we first added will look something like this. And that was the fertilizer. So the trial was set up in a polytunnel. The soil was sandy loam. And before setting up the polytunnel, it was covered with plastic for about 5 years. And during the winter, we had a green manure in the polytunnel, which we didn't incorporate, but we took it out. So we didn't put that fertility in the soil because we didn't want our soil to be too fertile, so we can actually get some result. But as you can see, as you can see with the results, actually our soil was very fertile, which is great for organic systems. So the tomato we used was the variety Douglas. It's a commercial medium tomato. And we transplanted them in May, and they were high-rise tomato, high-wire tomatoes. We pruned them and did everything a commercial grower does. And we did 14 weekly harvests of the fruit between August and November, and then we did 10 weekly application of the feeds. This is a picture of how our spacing worked. So each of these each of these shapes is one of our treatments where we put the different fertilizers. And then you can see this is the drip tape, and this is how our tomatoes grew. And this is close to, in the autumn where we were harvesting a lot of tomatoes, and this is how our tomatoes grew. So going to the results, we didn't actually get any significant difference. So there are liquid fertilizers, and we use them in 2 different concentrations. They didn't have any difference from the water, and that was quite an interesting result, although it wasn't significant, because we were wondering, did actually anything happen? Did we do any change in the soil fertility? So to answer that question, because there was no difference in the yield, we looked at soil mineral nitrogen. So, and what we found is that actually, yes, we did add nitrogen with our fertilizers. So this is after the final feed. You can see they are different from the water, and actually the difference happened even more after the removal of the tomatoes. The nitrogen in the treatments was much higher, significantly higher than the control and the water, and this continued 6 months after there was higher nitrogen. So yeah, so we could see that there was effect in the fertilizers, although there was no effect in crop growth, and that continued for 6 months. So the conclusion from our vegan fertilizer trial is that the background levels of fertility in this experiment were actually too high to demonstrate the beneficial effect of the feeding on the yield of tomatoes. So the soil was already very fertile, so our fertilizers didn't really make a difference. But this result confirms that organic production, organic growing systems, even in intensive cropping like in this polytunnel, they don't rely on short-term additions of nutrients. So as we say in organic horticulture, we feed the soil, we don't feed the plant. So our fertilizers, basically they were feeding the soil and started building the fertility in a soil rather than giving a boost to the individual crops, which is really interesting as a result, and confirms that in organic production, yeah, we don't need these quick fixes of just throwing a fertilizer in the soil to boost our yield. And as we saw from the results, the residual effects of the fertilizers lasted 6 months, and I'm pretty sure they will even last longer if we continue taking soil nitrogen readings. So the next theme of our research was the visits on the vegan organic farms. So we visited 8 vegan organic farms across the UK. And we used RISE, which is an interview-based method. So we did interviews for assessing the sustainability of farms, as I said, across in a holistic spectrum, across economic, social, and environmental dimensions. So looking at our results, this is the polygon we got from one farm, and that's quite a pattern that we saw across in most of the farms, is that in terms of economic viability, it's quite low. Vegetables are cheap. Growers don't make a massive profit from them, and in general, like food is cheap in the UK at the moment. But in all of the vegan organic farms, the quality of life, the farmers told us that they're very happy with their life. Biodiversity was quite low because they don't do a lot of biodiversity assessments, but in general, everything else was quite balanced. And as you can see, in a more balanced, another vegan organic farm that we visited, more balanced results. Similar, the economic viability is quite low, but everything else is quite balanced. So the patterns that we saw from the visits in the vegan organic farms are that vegan organic growers have chosen not to use animal products on the farms because either they didn't have access to them, there was no livestock around, or they were vegans and activists, so they made a conscious decision based on their ethical values not to use animal derived products and to be vegan organic growers. Another pattern is that none of the vegan organic growers mention any observed nutrient deficiency or reduced yields due to the lack of animal products. So they were all happy with their soil fertility. Actually, one of the growers mentioned that they have observed in general in the UK in the organic movement and something that they call soil obesity. So basically, organic growers putting too much organic matter, too much nitrogen, too much phosphorus, and that the vegan organic grower approach that he follows keeps his soil in a more balanced and in a more balanced way, and he feels that he doesn't add too much, especially with the use of green manures. And another pattern is that the vegan organic growers are confident that as there is a rise in vegan and vegetarian diets, consumers will start asking also like where, with the correct information, we start asking how their vegetables are grown and if there's animal products used in the process. So they see that there will be an increase in the market for vegan organic products. So this was my presentation. Thank you very much for listening, and feel free to ask any questions. Thank you.
Welcome to the next presentation. My name is Carolin Weiler. I'm from the Center of Organic Farming at the University of Hohenheim. I will present you the topic alternative fertilizers, vegetable crop rotation, the effects on the main crop and the following crops. So why did we focus on this problem? In organic horticulture in Europe, they are mainly working without animals. So therefore, they are strongly dependent on external commercial fertilizers, which are permitted in organic farming. Then we also have contentious inputs from conventional farming. That means we have like feather meals, pig bristles, or manure from intensive conventional animal husbandry. Also, we have conventional products from conventional origin, like, for example, vinasse that may contain pesticides in them. And there's also the problem of imbalances, like we have nutrient outputs via the harvested products that are not equal to the inputs from the fertilizers. Therefore, we have a risk of K depletion and also an excess of P inputs. And all of these problems mean that we need alternatives. So we need internal farm-based end sources, but also external fertilizers that are non-contentious. What are the solutions? The solutions are alternative fertilizers. The first one could be clover grass-based fertilizers that are produced on the farm itself, or could be from other farms. These fertilizers are vegan and are of organic origin. The other possibility are biogas digestates. They are from organic origin or can be from household waste. Therefore, when we use these type of fertilizers, we could close the rural-urban nutrient cycle. The last alternative that we use in our experiments are residues from organic food industries. For example, tofu whey, that's a residue of the tofu production. It's also a vegan fertilizer and it has an organic origin. Then I come to the field trial that we did in Hohenheim. It's a 2 experimental years in 2019 and 2020 with a 2-year crop rotation. And in our research or trial, we focus on the system approach. So we don't focus just on one single crop. We want to have the whole rotation. The field trial took place in the Organic Research Station Hohenheim in southwest Germany. It's on the sea level of 435 meters above sea level. We have mean temperature of 9.7 degrees. The precipitation is 740 millimeters a year, and we have a haploid Louisol from Løes. The crop rotation that we choose was an early white cabbage for direct consumption. Then we had a spinach, and afterwards we have a winter wheat for baking purposes. In total, we had 10 treatments or fertilizers that we used, and the fertilizer requirements were based for cabbage, and we applied 220 kilograms nitrogen per hectare for the cabbage, and the other crops didn't receive any fertilization. The treatments have been the control without any fertilization, and then we had 3 hybrid treatments. So one was the 100% treatment, and then we had 2 other treatments where they received less or more nitrogen, so we can compare the fertilizers with the hybrid treatments. Then we had clover grass silage and clover pellets, the clover grass-based treatments. After that, we had the biogas digestates. There was also clover grass in there combined with pig slurry and a little bit of maize. Then we had the tofu whey, the composted farmyard manure, and biogas digestates from household waste. Now I want to show you the nutrient stoichiometry of the fertilizers. On the bottom, you can see all the treatments. On the left side, on the bottom, you can see the demand of vegetables that they have. And all the nutrients are based on nitrogen. That's why nitrogen is at 1. And as you can see that the normal fertilizer used in horticulture, in organic horticulture, is horn-grit. And you can see when you compare it to the demands of the vegetables that it doesn't fit. So we have not enough P, and also K is not enough in the fertilizer. But when you can have a look at the composted farmyard manure, you can see that we have too much phosphorus and not enough potassium. But when you can then go to the alternatives on the right side, you can see that the clover grass silage and also the clover pellets, as well as the biogas digestates, suits quite well the demand of the vegetables when you compare the main nutrients. And then I want to show you some pictures of our trial, how we did it. So on the left side, you can see how we applied the biogas digestates by hand on the plot. In the middle, you can see the clover pellets. They are quite small, but they are easy to apply on the field. And on the right side, you have the chopped clover grass silage. So before we applied it, we had the big silage bales. We had to chop it and make it smaller. Then next, I want to show you the incorporation of the fertilizers. On the left side, you can see an overview about the applied fertilizers in 2020. And after the application, we incorporated the fertilizers directly with a rototiller. Then a challenge we had that was for the tofu whey, and as you can see, we also did apply it by hand. But when you apply, it has a high water content, so you have to apply a lot of liquid on the field. And in 2019, we flooded the whole plot quite a lot. Yeah, as you can see, that's maybe a problem for the farmers. Now we come to the first results. First, I want to show you the head yield of the cabbage. In our trial, we differentiated between marketable yields that were heads that were bigger than 1 kilogram, and then heads smaller than 1 kilogram were classified as non-marketable heads. You can see the marketable heads always on the left side in the black or grayish color, and then the non-marketable head yield is the blue one. And as you can see, for horngrit, we had the highest yield for the 100% treatment. But the alternative fertilizers, especially the digestates, but also the clover pellets and the tofu whey, did not differ significantly from the horngrit treatment. What you can see that for clovergrass, clovergrass silage really had less yield compared to the horngrit treatment, and you can also see that the marketable head yield and non-marketable head yield was quite close together. So we can see that we have comparable yields of most alternative fertilizers to the horngrit treatment, and for the clovergrass silage we have significant lower marketable yield, and it was on the level on the horngrit treatment that received 100 kilogram less nitrogen. Now to the spinach yield, you can see that we don't have any significant difference between the fertilizers here. We have a residual effect of the clovergrass silage on the composted manure. So you can see that compared to the cabbage yield, now the clovergrass silage received quite good yields that were higher than the horngrit yields, and also the composted farmyard manure had quite good yields. Now I want to show you some nutrient balances for cabbage and spinach, and the nutrient balances are the nutrient inputs of the fertilizers minus the nutrient output of the cabbage heads and the spinach. So we don't calculate the residues of the cabbage in this calculation. On the left side, you can see the control. There, all nutrients are in a deficit. When we go to the horngrit treatment, we can see that just nitrogen was in a surplus, but you can see that K is really in a deficit. Then we go to the composted farmyard as another standard fertilizer in organic farming. There you can see that we really have a lot of surpluses even after 2 crops. Yeah. And then when we go to the alternative fertilizers, you can see here in the middle, the clovergrass silage, even if it didn't have the best yields, has quite good nutrient balances, but also the clover pellets seem to give the cabbage and the spinach enough nutrients. But also the other fertilizers were quite good in comparison to the horngrit with a deficit in the K, and also the many surpluses of uncomposted farmyard manures. So overall, we can see we have high K deficits from most fertilizers, phosphorus surpluses for composted farmyard manure, and the most balanced nutrients was for the clover-based fertilizers, but for clovergrass silage, we had the lowest yields. And then we come to the last crop in our rotation, the winter wheat. Here we have the kernel yield of the winter wheat, and you can see that we don't have any significant difference between the fertilizer treatments. It's just between the years where we had the differences. And here we also can see the residual effect of the clovergrass silage, which had the highest yield of the alternative fertilizers compared to the other ones. But overall, it was not significant. So now the questions: are the alternative fertilizers really suitable for organic horticulture? And here we have like a table to make like an overview. For the fertilization effect, we can say that the clovergrass silage has a low or medium fertilization effect because it took some time for the clovergrass silage to really have the nutrients available for the plants. For the other fertilizers, for clover pellets, biogas digestates, and household waste, they had a high to very high fertilization effect. And also the tofu whey had a good medium to high fertilization effect. So it was, the nitrogen especially was fast available for the plants. So for the excess, so that means the availability, the clovergrass silage is really easy available. It can be produced on farm. Also, clover pellets could be produced on farm, but you can also buy them, so they're commercially available. And the other three fertilizers, the digestates and the tofu whey, it really depends on the region you're farming. So if there is a biogas plant nearby, or also if tofu whey is produced nearby. Then to the costs, the clovergrass silage is quite low in costs. You can produce it by yourself. The clover pellets, the costs are quite high per kilogram nitrogen. At the moment, it's at 20 euros here in Germany. The biogas digestates have quite low costs. And for tofu whey, it's low to medium, and it really depends on the transportation costs. So how far are you away from the tofu whey production? Then the contamination risk of plastics or heavy metals also on. For clovergrass silage, clover pellets, it's very low. The biogas digestates that are clover based, it's medium to low. It always depends on the input. For the household waste biogas digestates, it's quite high, but it's always depending on the source, so what they feed the plant with. And for tofu whey, the contamination risk is really low. And then the last one is the suitability. All of them are really suitable for organic horticulture, but for clovergrass silage, maybe an early application would be beneficial. So maybe we can apply them in autumn so that the nutrients are really available for the next plant. But it really depends then on the regulation of the country, if it's allowed or not. What are the challenges that we have? The main challenge is the acceptance by the farmers. Are they willing to pay for the higher costs or for the alternatives, especially for the clover pellets that have a really high price per kilogram nitrogen, and also the risk of perception of contamination. So there's always the risk, are there pesticide residues in there, and also microplastics. And there are lots of unsolved practical issues. For example, tofu whey, as you have seen on the picture, they have a really high water content. So you really flood your field. And I think we really need some technology inventions in there, so we have less water that we have to transport. And also the availability of the fertilizers, I think, is a really, we have to solve this issue. So especially for the tofu whey and the biogas digestates. And then another challenge is the different regulations on the fertilization within the EU countries. So you have to keep that in mind, and all of them are quite different. And also the regulations of the farmers associations have to or you have to keep them in mind, because not all of them allow the use of biogas digestates. Here in Germany, you're not allowed to use biogas digestates from the household waste in Naturland, Demeter, or Bioland, for example. So now I'm done with my presentation. Thank you for listening, and hope you have some questions for me later. Thank you.
Welcome, everybody, listening to this presentation. My name is Frank Altshoorn, and I am working for the Innovation Center for Organic Farming in Denmark as a senior scientist. I do research on the sustainability of organic farming, and especially also on climate change and on biodiversity. And in this session, I would like to present some work we have been doing for the Organic Plus project, where we have evaluated some organic farms that are trying to find alternatives to conventional manure. So just to introduce the essential nutrients that we have to use in organic farming are nitrogen, phosphate, and potassium, among others, of course. And as now the possible inputs that are allowed or permitted in the organic regulations are livestock manure, or digestate from manure, or maybe purified manure as pellets or dried. Then, of course, it's allowed to use legumes, which also produce nitrogen by taking it from the air, and some waste products that also contain nitrogen. Then we also have phosphate, again, mostly from livestock manure, but also possible to use rock phosphate or precipitated phosphorus salts from wastewater, which is quite new, but coming in the regulation, biochar and bone meal, and then potassium, also again from manure or digestate as above, but also from natural sources and from waste products. So we can see that that livestock manure is very essential in organic farming for fertilizing arable crops. Of course, we have to manage as little losses as possible, no leaching and no emissions, but we have to have some input. When we evaluate the sustainability of farms, we use a program that's called RISE. It's standing for the Response-Inducing Sustainability Evaluation. That means that we actually want a response from the farmer. It's a farm tool that is made to help the farmer make decisions and try and actually let him or her improve the farming. The process of doing this is by finding the data of the farm, mostly in databases, but also from accounts or other storage of data. And then we interview the farmer for some extra questions, also visiting the farmer. Then the advisor that does these assessments makes the calculations and presents the calculations to the farmer, where they are discussed. And then an action plan is made for the farmer, how things can be improved or maybe followed up. The farm tool then presents the results to the farmer. And you can see on this slide, it is presented in the beginning as a polygon, or this spider web, showing all 10 themes that are evaluated. The themes you can see here: soil use, animal husbandry, materials and environment, water, energy, climate, biodiversity, working conditions, quality of life, and economic viability and farm management. And these 10 themes are calculated as scores between 0 and 100. And they are calculated by averaging the indicators, which are the black dots that you can see here in this polygon. And then the red line represents the average scores. This is the way it is presented for the farmer, but of course the farmer can also see more details. You can see an example of a calculation here for the first theme, the soil use. It exists of these 5 indicators: soil management, crop productivity, soil organic matter, soil reaction, soil erosion, and soil compaction. And well, for instance, here the crop productivity can be calculated as an average of the yields of the crops. Yeah, the soil organic matter is is calculated by seeing how much input of organic matter there is on the farm. The case farms that we evaluated in the Organic Plus project were one vegetable farm in Spain, some vegan farms in the UK, and a potato farm in Denmark. The vegetable farm in Spain was using composted conventional manure and also trying to use alternatives, finding legumes, intercropping. The vegan farms in the UK were obviously not using any organic manure, also not the conventional manure, of course. They were trying to use green manure, and they imported waste which they composted, and they also bought some ready-made fertilizer. And the potato farm in Denmark was using large amounts of conventional pig slurry, but trying to find alternatives by using digestate from organic sources. We then evaluated the farms, showing these polygons and looking more into details. And here you can see the result of the vegetable farm in Spain, which performed quite good. The red line is mostly in the green, but you can also see that the soil organic matter and the soil management and the soil reaction were not in the green. We can also see that in the materials and environment, here the fertilization and the material flows were in the yellow, which means that they could be improved. Also, I show here that the biodiversity was scoring 68, which was rather good, because the vegetable farm also had a lot of different crops. The vegan farms in the UK here, I only show one. The vegan farms, they had generally a problem with quite low yields in the registration done by the advisor, but it was also mentioned that the registration was difficult because the vegan farms were not always harvesting everything at one time, and the areas were very small, so it could be differences in the measurements of the area. We can also see here that actually the biodiversity score was quite low for some of the vegan farms also, even though they had quite a lot of crops. But biodiversity is more than only having different crops. We can see here also that the economic viability was very low, and that this was general for the vegan farms in the UK. But it was also mentioned that these farms were community-supported agriculture, so they were not really dependent on the income of the crops, because they were supported. They were supported by the community. The potato farmer in Denmark was a large farm, about 300 hectares. So really dependent on the import of fertilizers, as they had no livestock in themselves. None of the farms that we evaluated had livestock. Here you can see that the yields were also generally in the yellow and the red, so quite low. Mainly because the farmer could not get more fertilization than used here, maybe only about 60 kilos of N per hectare. Biodiversity was in the yellow, but I also want to stress the fact that sustainability is very many things, and the quality of life on this farm, for instance, was really good. So the farmers were very satisfied. We had a discussion afterwards about these farms and the sustainability performance, and talked about conventional manure and the reason why to find alternatives. One of the reasons mentioned was that when using conventional manure, we can import antibiotic-resistant bacteria on the farm, which can actually live in the soil and maybe also even contaminate the products, the vegetables that are harvested. But also one of the reasons is that we don't want to be reliant on conventional productions, especially not if it's factory farming. So these were discussed. How important is it? Is it possible to hygienize the conventional manure for not having antibiotic resistant bacteria, for instance, by composting or by biogas fermentation? And here the composting process is actually better, which the farmer in Spain was using. Vegan producers, they of course don't import manure, but they import other fertilizers, and it showed also that they were not really registering so good what they were importing and what the things were. So it was difficult to analyze exactly. Can be difficult to validate the yield levels also. The general problem is also when we fertilize the crops with low amounts of nitrogen, phosphorus, or potassium, we can get very low open crops, giving a possibility for the weeds to grow. So we need more labor to conquer the weeds. So there's always these synergistic things that are happening when we have fertilization. Green manure is a possibility. Clovergrass in the rotation, but clovergrass is often not giving any income. So that's why it also has to be considered always if this is possible. The conclusions for our evaluations were in general that lack of nutrients is a challenge, especially for the bulk productions, the large areas where organic manure is not always available because there still are very few organic livestock farms in some areas. But also a conclusion was that sustainability of farms is many things and not only dependent on high yields of the crops, for instance. The vegan systems were challenged also by lack of nutrients. No, sorry, they were not challenged by lack of nutrients, the ones that we evaluated, because they were getting material they could use as a compost from the community, and it were very small farms, so they had the possibility to use this. This was enough. And in general, it was also discussed, and the conclusion could be that low nitrogen levels could actually improve the biodiversity. Because the farms are less intensive, and in this way giving possibilities for more biodiversity in the crops. Yeah, so this was our conclusions from this session, and you are always welcome to come with questions afterwards. Thank you.
Hello, everyone. My name is Lucius Tom. I'm coordinator of Relax, of the Relax project, and I'm happy to tell you a few things of what we've achieved and can contribute to our overall objectives. Relax stands for replacement of contentious inputs in organic farming systems. It's a sister project to Organic Plus. Our objective was to evaluate solutions and to further reduce the use of external inputs and to develop and adopt cost-efficient and environmentally safe tools and technologies too, and that's the important point, to reduce the use of copper and mineral oil in plant protection, to identify sustainable sources of plant nutrition, and to provide solutions to support livestock health and welfare. And our concept from the beginning was, of course, to build on results of previous research projects and to take far advanced solutions forward. So that's the underlying concept. We have included 13 European countries of academia, research institutions, but more importantly also many farmers associations to do on-farm research. So we have quite a large-scale consortium involving many stakeholders from different groups. Okay, this is the group photo of our consortium when we started off, and all the contributing partners there, including one of Spain. But I would like to put our activities in a broader context related to what we need to do to move forward with organic farming. So as you all know, there are some global challenges for agriculture. So like soil degradation and climate change, water use and pollution, but also loss of biodiversity. But nowadays also in the political situation, the yield security issue has become very important again. So we have to comply and contribute to these overall objectives to provide yields, but also to reduce the environmental impact. And as you all know, organic farming contributes or performs quite well if it comes to productivity in subsistence and smallholder farms. It creates value, added value in food chains. It has all sorts of benefits to the environment. But there is the famous yield gap, and this is one of the problems we are facing and which we have to address. And I'll come to that in a second. The benefits of organic farming and its potential contribution to agriculture have been recognized at the EU level and in many member states, in particular in Europe. And therefore the Farm to Fork strategy foresees very ambitious goals to upscale organic farming to 25% until 2030. And what you can see here in this graph, this means a tremendous increase of the surface in a short period of time. And this puts all sorts of challenges to us, to the actors, on how to achieve this transition and how to achieve these objectives. It's logistics, it's training, it's market, all aspects of the organic sector are involved. So when we talk about challenges to organic farming, then I would say we need to increase productivity to close the yield gap while retaining the benefits to the environment. So we have to avoid the collateral damage to the environment. We also have to replace problematic practices, and this is what Organic Plus and Relax are about. And we also have to find ways to allow for upscaling for organic farming. So that's also a major challenge in logistics. The timeline of Relax was when we started off. We started off with data collection. Where do we stand? What's the state of the art? We identified the needs in surveys. What is used right now? What are the alternatives? We did develop and customize available alternatives. We tested them on farm in various countries and contexts. We also looked at the socio-economic, environmental, and acceptance issues for novel solutions. And we've also developed roadmaps to be presented to the European Union on how to implement those alternatives if it's possible, and on how to reduce the use of contentious inputs. The state of play is, yes, we see, in a nutshell, yes, we see that there are alternative tools and technologies, and they may contribute to the reduction of these contentious inputs in many cases, not all. The transition to improved management practices has to involve all players along the value chain. That's totally clear. There are very different there is a different potential for introduction of alternatives, but there are also different bottlenecks in each case which may hinder the transition. So they need to be identified in each case. We need tailored support strategies from the policy side, because else nothing will change. We also identified actions that are needed at the EU level to encourage the use of alternatives and to encourage the reduction of contentious inputs. And as I said, we have drafted some roadmaps to reduce the use of contentious inputs, and those roadmaps, they have to be fair, reliable, and also implementable. It's no use to claim everything is fine if there are serious problems. What I want to raise here is we've addressed some aspects, but if we want to improve organic farming and further introduce further innovations in organic farming, really to address the demands from the world, to feed the world and so on, then it's not only about technological innovation, it's really also about social innovation and ecological innovation. And these are aspects we have not addressed in RELAX because that was not the purpose, but we have to keep in mind that these other avenues or roads for innovation need to be addressed too in order to achieve major progress for organic farming and agriculture in general. I'm going to give you just in a nutshell the conclusions of our findings with respect to plant nutrition. So the availability of manures and fertilizers and so forth to the organic sector. The key item here is that with the increase of the organic sector, there is quite a bit of logistics involved to make available nutrients to the plants as they are needed. What our colleagues found in a quite a large survey is that generally the importance of nutrient supply in organic farming has been underestimated in many places. There are several areas in Europe where soils are actually mined for available nutrients like phosphorus and potassium, and the supply is insufficient. The other issue is that the market supply for fertilizers accepted in organic farming is rather limited because it needs huge amounts of materials, and already now the prices for such fertilizers are increasing quite rapidly. As a conclusion, they say the importance of nutrient supply has been underestimated. There is urgent need to address this bit in order to provide the supply to the organic farms. We believe that we need to phase in some of the recycled nutrient sources. So from recycled materials, but of course it's absolutely necessary that the safety of these products is guaranteed. And that consumers and farmers are accepted the way of production, but also the way it's handled. So there is need for guarantee on the quality of these products. There are no criteria or little criteria yet for the approval of novel recycled materials. So the organic sector has to develop and to agree on such criteria in order to meet the expectations by consumers and by farmers. And the supply of sufficient nutrients in Europe, this really involves significant financial and logistical support, and it needs to redesign in some areas, some regions, the redesigning of waste collection systems. So this is a huge challenge. We've underestimated it at the beginning, but we are now convinced this is one of the major bottlenecks to be addressed in the future. Where will you find more detailed information of the findings? So there will be detailed reports on alternatives and their potentials on our websites once they are approved by the Commission. There will be also a report on the reduction strategies, and there will be practice abstracts on the individual solutions, and I give you just a flavor how this looks like. So one of the practice abstracts, that's the general format. This one is on large bug extract on copper use, but they more or less look like this. They are currently being put on the website and published. So you're welcome to have a look and check where you can find them. The more detailed reports on the roadmaps for phasing out, these are the results of national and European workshops in which maybe some of you have already participated. These are rather detailed reports, 20 to 30 pages, where you can find all the details which ultimately lead to the conclusions and recommendations. And of course, all the other information you can find on the project website as usual. So thanks a lot, and feel free to contact me or the colleagues anytime after this seminar.
Hola, bueno, ara ja és el vostre torn de paraules. Podeu escriure la pregunta al xat que us apareixerà baix a la pantalla i, sisplau, si indiqueu a qui va dirigida la pregunta, ens facilita molt després per la resposta i no estar mirant a veure qui pot respondre-la. Hi, now is your turn. It's your turn to ask. So you can type the questions that you want to do in the bottom, in the chat that appears in your screen. Please, if you can indicate to whom the question is addressed in order to facilitate the answer. Avui tenim amb nosaltres la Carolin Weiler, en Casper Laursen, la Judith i l'Ulrich Schmutz, així com la Judith Conroy i en Francis Ryans, que, tot i que no han parlat avui, estan en el grup de treball amb el que està també l'Anne-Kristin Løes i en Touliatos, que excusa la seva assistència i avui no s'han pogut connectar. Today we have here with us Carolin Weiler, Casper Laursen, as well as Judith Conroy and Francis Ryans, who are speaking on behalf of the work package that they work with Anne-Kristin Løes and Touliatos that they has not been able to connect today. Per tant, quan vulgueu, us podeu començar a fer preguntes. També amb mi hi haurà la Marta. Hola. If you can connect, Carolin and Casper, the camera and the microphone, please. And Ulrich and Marta Bojar. The translations today, the questions that you ask, I will translate the questions, and the answers, they will be translated by Marta Bojar. Thank you all for being here. Les preguntes les aniré llegint jo i traduint-les i la Marta Bojar aniria fent la traducció dels ponents a les respostes que us donin. Aquesta primera pregunta és pel Casper Laursen, que demana com separen les bosses de plàstics o altres impropis dels residus orgànics per després utilitzar-los com a biogàs. Casper, this question is for you, and they are asking how you do it to separate the plastic bags and other plastic or whatever doesn't work properly from the organic waste to be able to use them and make biogas from this waste.
So you can hear me, I suppose?
Yeah, we hear you perfect.
So I suppose that this is actually not an agricultural question. It's more a technological question. the pre-treatment plants and some of the biogas plants as well, they have these methods or these technological ways of separating plastics. So it is a technological question more than anything else, I suppose. So it's not my field of knowledge, I have to say. But it's a mechanical way of getting rid of plastics. Yeah.
Se'm sent, oi?
Sí, perfecte, Marta.
Recomenta en Casper que no és una pregunta relacionada amb l'agricultura, sinó que és una pregunta més aviat tecnològica i que, bueno, que se suposa que s'han servit mètodes tecnològics i mecànics per separar-ho, però que ell poc que entra en aquest tema no sabria dir exactament com funciona.
Perfecte. Well, n'hi ha una altra. Ulrich, this question is for you. Pregunten a Ulrich com afecta la nova legislació europea en matèria d'agricultura ecològica al creixement previst d'hectàrees en transició a l'agroecològica. Legislació europea en matèria el creixement previst d'hectàrees. Vale, bueno, entenc que la legislació serà la mateixa. Li preguntem. I am not really sure about what they are asking. Maybe later it's more clear. But the translation should be something that how the new European legislation in organic agriculture has there is a growth, okay, of the number of hectares in organic agriculture and how does affect the new European legislation. I really don't know the question, what there exactly do you, we hear you, you should switch on your microphone, Ulrich. No, it's in the top of the screen. Now.
Hello? Now
Yeah.
it's on. Yeah.
Yeah.
Okay.
Perfect.
Yeah. Thank
now,
you.
now.
I try to answer the question. I think first of all, what Lucius showed is the 25% target is for the whole of Europe as an average. So there will be some countries like Austria who already at 25%, and also Germany who has a target of 30%. So some of them will kind of overshoot or attempt to overshoot that target. So it will be most likely that other countries, I wouldn't want to name some, but some of them were quite low in organic percentage. Let's say Ireland, for example. So they will probably stay under that. And the EU regulation, I think the new EU regulation is obviously here to help organic farming to reach that goal on average. And some countries obviously may choose to go higher. And I think also what was that very clearly from Lucius there is that then the overall fertilizer availability is just a different question. If you are, somewhere below 10%, it's not such an issue. But once you are at 25%, you are just looking at a different scale. And I think this is a real big challenge for the whole of organic sector to deal with that scale. And it came also out in the discussion what Dennis said earlier about vegan, which is currently clearly a very small niche, and some people want it to be a niche, but it also will have to change if it wants to go in a much bigger scale. So maybe that's what I can answer here for that question. Our work, Relux and Organic Plus, will also lead to a new organic regulation, probably in 8 or 9 years' time, because that's what phase out means, that certain things will be phased out, but other things also phased in. I think Lucius also said that, so maybe some recycled fertilizers need to be phased in. We're also working, that's the final thing, to answer the previous question, we're working on alternatives to plastic, which are biodegradable, and we hope that this will also eventually help solve Casper's problem in a way that digestate doesn't have any fossil fuel derived plastic. So it will have only biodegradable things, which then will be kind of digested in a digester nicely. But also a little bit further research is needed for that, because the biodegradable bioplastics may have additions as well, which may have issues. Okay, thank you.
Vale.
Vale.
Bé, primer que...
It's difficult to translate, I'm
Thank
sorry.
you for making it so easy and so short. That's okay. I think I got it.
Yes, just take the most important things. Yeah.
Yeah, exactly. Primer parla de que, bé, com les regulacions europees poden afectar a aquest augment d'hectàrees d'agricultura orgànica, diguem, i el que comenta és que el 25% que està com a objectiu és una mitjana entre tots els països europeus. Hi ha països que ja l'han assolit, o fins i tot Alemanya, que té, crec, un objectiu, ha dit, del 30%, i hi ha altres països com Irlanda, que només és un 10%, i que de moment, doncs, el que es fa és una mitjana. Per tant, no afecta específicament un país en concret, sinó a Europa com un tot. Això és el que pot dir respecte a aquest augment d'hectàrees. Que ell, el problema que veu ja no és tant una qüestió del terreny, sinó en els fertilitzants que es necessiten tenir disponibles per utilitzar en tant terreny orgànic, que ara mateix per un 25% de terreny per agricultura orgànica doncs no es té. I bueno, doncs, creu que projectes com Relax i com Organic Plus doncs, el que faran és crear encara més normativa o més necessitats a partir de, doncs, per exemple, utilitzar fertilitzants reciclats i altres coses que aniran sorgint. També ha parlat doncs, dels plàstics biodegradables, etc. Però bueno, crec que tota aquesta resta de coses que ha comentat no van tan relacionades amb la pregunta, però que li ha volgut posar el focus a que ja no és tant un problema d'augmentar el terreny, sinó de com fertilitzar tot aquest terreny, precisament.
Val. Gràcies. Ens fan un comentari sobre la primera pregunta que anava cap al Casper, que deia comentava sobre els impropis que hi ha en els residus i diu que el millor és evitar l'entrada de plàstics als sistemes de transformació de subproductes orgànics. Òbviament, cal augmentar la conscienciació per separar bé a casa i que realment la normativa cada dia és més estricta per evitar o reduir, sobretot, l'ús de plàstics. There is a comment about the answer, about the question that they made before for Casper, or to Casper, okay, that it is best to avoid the entry of plastics into organic byproduct processing systems. Obviously, it is necessary to raise the awareness of the population to separate well or properly at home. And in addition, actually, at least in Spain, are more regulations to prevent or mostly reduce the use of plastics. Okay, just to comment. There is a question for Caroline. Una pregunta per la Caroline. Per la Carolin és si els digestats estan higienitzats i quines són les possibles afectacions als cultius que han estat assajant. Carolin, this question is for you. They ask if the digestates are sanitized and which is the possible damage to the crops that you have put in the trial, that you have done in the trial.
Hi, so the fertilizers received for the digestate fertilizers, they are sanitized in the process of the fermentation. So because they have been on a certain temperature during the fermentation process, then they are sanitized after that. The fertilizers we applied we didn't get any damages on the plants because we applied them before we planted the cabbage. So you're not allowed to apply them overhead on the vegetables because you will eat them. So that's not allowed. But if you apply them before planting, everything was fine there for our digestates.
Comenta que el procés d'higienització es fa durant la fermentació, i a l'estar a una temperatura determinada això fa que no tinguin cap possibilitat de causar danys al cultiu i que, a més, no està permès aplicar-los un cop s'han plantat, que aquests digestats s'apliquen, els fertilitzants a partir de digestats s'apliquen abans de plantar. Aleshores, això no té cap problema cap a la planta, no afecta.
Hi ha un agraïment per la resposta tan completa que s'ha fet l'Ulrich i és una altra pregunta que també li faré a l'Ulrich, que és que si hi ha algun pla per continuar la recerca, més que res perquè ell és el responsable de tot el projecte Organic Plus, és l'entitat, forma part de l'entitat líder. I aquesta persona diu que treballa en viticultura i que estaria interessada en provar alguns mètodes. Li traspasso això a l'Ulrich. Ulrich, they say thank you for your complete answer. That was what he was looking for. And there is another person that asks if there is any plan to continue the research. Because he works in viticulture and he will be interested in trying some of the methods and alternatives tested in the project. And they give us a mail that I can, well, you can, I don't know if you see it, or I can send you by mail later on. And
yes, so the answer is that these projects are time-bound and ours still goes on. It has an extension for 6 months, but it will be ended by the end of this year. And then there is plan to continue. The Horizon Europe has put up a lot of funding for it. Some of them will be also innovation actions, so where we will be doing maybe less lab research and more innovate together with farmers and you know, we are the first ones to admit that there are lots of things we haven't solved. Also, I think we can be quite proud what we have achieved, but there is a lot left to be doing in the area, including this 25% rise. We haven't also worked on all the crops. We have done olives and citrus, and Lucius' team in Relax have worked on roses in Bulgaria. So we have done quite a few things in terms of, but we in our team we haven't done viticulture. So I just have to say that wasn't possible. We've done potatoes as well, which was a big crop. But we also didn't look into apple and almonds. I think almonds is an important thing. We didn't do that, but we looked into greenhouse crops and also aubergines in Turkey. So I think every crop needs its own extra solution as well. So and yeah.
Okay. Comenta que el projecte està previst per 6 mesos, que això acabarà a finals d'aquest any i que la Unió Europea ha invertit molt en tots aquests temes i que, per tant, es plantegen continuar investigant, no tant a nivell d'assajos i tal, sinó més en innovació. I pel que fa als cultius, sí que és cert que han treballat amb alguns cultius, crec que he comentat roses a Bulgària, patates i tal, però que, per exemple, en viticultura no s'ha treballat i tampoc en pomes, que creu que pot ser uns cultius en els que s'ha de treballar, s'ha d'investigar i que realment cada cultiu té unes necessitats determinades. Així que bé, sí, s'hauria de treballar en cultius específics.
Bueno, I think that all of you have been pretty clear in your presentations because today there is no much questions. Crec que han sigut els ponents molt clars perquè la veritat és que no apareixen més preguntes. Si no hi ha més preguntes ho deixaríem aquí i donaríem les gràcies a tots els ponents per haver-se connectat. I see that there is no more questions, so I guess that was everything clear. So I will thank you. I want to thank you in behalf of l'Escola Agrària for being here and connect to stay for our attendees. I dir-vos que les presentacions i els vídeos, si els voleu tornar a veure o us heu perdut alguna part, estaran disponibles, les entrarem, com que això és un cicle de jornades, de 7 jornades, les entrarem al mes de juliol, totes de cop, i llavors a partir de la primera o segona setmana de juliol estaran disponibles. Just remind you that this is a cycle of conferences, so we will put them, all the recordings, they will be available in the web, RuralCat, during the month of July, and we will put orange all together. So if you need to watch them again, then they will be there available. Moltes gràcies, Marta, per les traduccions. I si no hi ha res més, thank you very much all for being here. See you soon. Bye.
Bye.